Good day, everyone. Thanks for all joining us and having another conversation regarding manufacturing. And we have a very special guest with us, Mark Blosser. And Mark is from a company by the name of Ceratizit. And it only took me 20 minutes to make sure that I said it right the first time. Ceratizit. It's really kind of easy to say it after you've said it a bunch of times. So Mark, yes, thanks for joining us today.
Thank you. Appreciate you having me.
So I don't know whether to ask you first about you and your background or how Ceratizit came to be. So why don't we start with you?
Okay. As you started off, my name is Mark Blosser. I'm the technical director for Ceratizit, pretty much for the NAFTA region of the world. I handle pretty much all the automotive business that we have between Canada and the US and Mexico. Been with the Colemet for 38 years. They were purchased by Ceratizit a few years back, and we became part of the Ceratizit umbrella at that particular time. So I've been in the industry for 38 years now.
Okay, so let's get right to the beginning. And why don't you give our listeners the URL for your website? And I would spell it slowly.
Okay. www.cuttingtools.ceratizit.com. So that's www.cuttingtools.ceratizit.com. C-O-M.
Excellent. And if you didn't all get that, you'll be able to see this on our website at Manufacturing Talk Radio, if you go to listen to it again. So Mark, give us a little bit about your background. Seemingly very strong engineering background,
Yes.
dealing in projects and customers and so on and so forth. I gather you've been doing this a while.
Yes. Yes, I've worked in multiple industries and over multiple platforms, pretty much from the conception stage all the way through tool design and runoff in regards to most of our major customers. And that's pretty much been all the way up around down the East Coast of the United States and Canada and Mexico. So my team works from the conceptual part of a part. We design a process around it. We design the entire tooling package associated with it. And then we support the customer at their site, actually setting that machine up with the tooling and making capable components.
So the parts that you're making are, to a great extent, obviously automotive. Is this tooling for the manufacturer to make a part, or are you actually making tooling so that the part could be made?
We're actually designing tools that actually cut the part to its finished characteristics. So a customer could have raw material, it could have raw castings. Once we have that information, we develop a tooling process with the machine equipment they have specified from the OEMs and design a tooling package in the process to actually cut those parts from raw material to finished components.
So you're creating the software for...
No, actually, it's the hard cutting tools. So if you can imagine a tool that's, you got a part that's got a hole in it, it actually creates the hole inside the part.
Got it.
So it's metal cutting.
Okay. So the automotive industry obviously is a very large and strong industry, except for maybe this year and last having something to do with the dirty word chips.
Correct. That's pretty much caused an influx in regards to production environment that we're in right now, that we don't have chips to actually make finished components. So there's lines that have been shut down or halted prematurely or temporarily because we have a supply chain problem with actual chips coming from Asia. And that's an industry-wide problem now.
There's a lot of issues in Asia right now that are affecting this yes. country. We've had many conversations here about the U.S. tariff on Chinese goods and what that's really doing to the American public and American manufacturing, and it's not good. So, but that's a whole other discussion that isn't going to get cured anytime soon.
Right, and there's a pent-up demand for vehicles now. I mean, if you go down the street, you can go buy many car lots are all basically empty or very limited in regards to what they have from availability. So that's a problem everywhere.
Yeah. I don't think used cars have had such a good period of time as they are now.
No, that's true. I mean, because you can't buy a new car, your used car prices are being increasing on a month-to-month basis. So
Sure.
it's difficult to get a car right now.
Sure. So I presume that you're selling into the large manufacturers, the standard Ford, GM, and so on.
Yeah, we sell to the primaries as well as pretty much every one of their tier 1, tier 2, and tier 3 suppliers. So it's got a broad fingerprint or footprint in regards to the United States. Because if you think about a car and all the components that go into those vehicles, it touches many different subcontractors that supply the big three. And as well as the Asian imports and German imports that we actually have in this country as well, because we're pretty much got all of the automotive footprint here in the United States, not just buying it out of Europe. So it affects a lot of different manufacturers.
Yeah. Is there any one country that produces better parts than another?
No, I mean, realistically, the technology and the automation of things, most of the countries that you deal with are using relatively newer equipment, and they've developed processes that are pretty much common all over around the world. If you think about the big three and how they put footprints everywhere, they have a best practice protocol that they use. So they pretty much adopt that all around to different countries. So the quality aspect of it is relatively good for most of the places that you would buy them from, because there's controls in place.
Right. That's like ISO standard, where the ISO standard has gone around the world and everybody's doing the same thing the same way, time and time again.
Right.
We've been my primary business, All Metals and Forge Group, has been ISO'd since 1994.
Right.
So we were really early adopters into it, and it's really been quite incredible, where everything is done the same way every time, no questions asked, and it's really saved us in many bad situations. So
to expand on that same thought process, part of our group we have is a process monitoring group. So we have this apparatus that you can put on any piece of equipment and actually measure based upon what that machine is doing at all the times, and create a digital footprint of the manufacturing process that you actually can put controls on to how you make something that you never deviate from it. So that's part of the industry 4.0 that you might hear around.
Sure.
The buzzword around regards to that at a lot of different places. So we have a thing called tool scope that you can put on a machine, and once you teach it how you make a part, it monitors how you make that part every single time and make sure that you never deviate from a standard. And that's actually part of our group that specializes just in that area.
So one of the concerns in the manufacturing world, at least from the standpoint of employees who are working on the shop floor, and that is about job loss, and they're taking our jobs away, and robotics and so on and so forth. Does your what you're doing and what you're using in your technology, does it take away jobs, or is it actually adding a new kind of job?
It realistically isn't changed the manufacturing footprint in regards to how things are made. It's just monitoring how we are making and making sure that we don't deviate from a known standard. So from that part of it, that is correct. We're not really affecting the manufacturing employment base. We're just making sure that the parts that they make are always very consistent and always coming out with the same quality. Now, there is other things that are happening within the industry, which is going to have broad implications, which is the change from a combustion engine powertrain to a electric stator or power by battery type scenario, because there's just less components in an automobile that actually have to be built now. So that might actually have some impact on our manufacturing base, but it changes the technology from where you would use powertrains in regards to an engine, cylinder block, cylinder head, transmission, and you're now making electrical components. So you just have a dynamic shift in regards to the skill set of people that are required for those components.
I think the next dynamic shift, which I just heard about fairly recently, and that is that one of the Japanese automakers is now going to be making hydrogen engines.
Yeah.
And that's going to be a major positive effect in many different areas.
Right. Well, I mean, in regards to battery and the whole e-mobility thing that everyone's talking about now, one of the things that I struggle with is what do we do with the raw materials for batteries, and how do we get rid of those batteries once they've been expelled? It's just like your double A's and those kind of batteries you don't really want to throw in a garbage can, so you don't want to put them in the landfill. So we're going from one thing with fossil fuels and burning that off in regards to what that's doing to the environment. And I don't think we've really captured the environmental impact of what we're going to do with all the batteries once they've been expelled. So that's something we're going to have to basically review going forward.
I have the fix for that.
Yeah.
You take all the batteries, you give it to Elon Musk, put them in a spaceship, and just send it off. And that's it. It's done. Yeah. The problem is that it may wind up coming back around. So I'm not sure if that's how that's going to work. But
if you think about it in regards to a battery and the size of a car, it's not a small battery; it's a large battery.
Right.
And if you're producing 17 million vehicles a year in the United States, that's a lot of batteries. So
we can fill it up in where the oceans used to be.
Yeah. But I think there's going to be a whole industry that's going to pop up just on reclaiming the raw materials out of batteries and what we're doing with recycling of batteries once they get out of a car. So I think, like you said, and I think there's a gigantic shift in regards to what type of manufacturing we're going to be doing and the resources that we're utilizing.
That's an interesting point you brought up about what are we going to do with all the raw materials. Towns are beginning to, local towns are beginning to have monthly or bi-weekly events at town hall sanitation departments to turn in your old computers, your old batteries and so on. And they are salvaging whatever those raw materials are. And I don't think they do it enough, but it shows that there's a step in the right direction.
Right. Well, I mean, long term, if that's the platform we're going to all be utilizing going forward, we're going to have to figure out what to do with that. So I even go in regards to, like, you go fill your car at the gas station, you're going to have these charging ports all over the place that you basically have people stop their car, plug their car in, and then you're going to have to, what are these people are going to do while they're sitting there with the car getting charged? So you're going to have to set some kind of entertainment venue or food venue in regards to where these cars are sitting. So you got that whole thing we have to start thinking about. So again, there's multiple changes being in the forefront.
Well, they can put in a bar. So hang out.
No, I'm not condoning that, Lou. I mean, that's the whole drinking and driving thing. But yes, that's something you could do.
Yeah. A strip bar or something like that. You know?
There you go.
Keep it really interesting.
Yes.
Well, so where do you see? And I know it's not really in your genre, but with regards to the chips, and this is a major problem.
Yeah, it's a global problem. I mean, right now, the biggest, what we're going to realize, what we're all going to realize is that you can't source these components from one area of the country or of the world and think that you can just use that as your one place to actually procure those components. So I think some of that's going to come back domestically. So we're going to have to start making some of our own chips. We're going to have to be domestically sourced for that. We can't rely on other places of the world. So I think that's going to change some of the way we procure products. So. Yes. And
I also heard recently that the chips that they're making today, in 9 months from now, they're old.
Yeah.
Technology changes every 9 months.
Yep. Yeah. It's true. That's true.
It used to take 200 years to make change. Now it takes 9 months.
Yes. Yeah. It's amazing. I mean, you go from one season to the next, just go buying a TV, and what the bells and whistles they put on a TV. It's amazing. So I remember when I first went in the field, long back when I got out of school, I used to program computers, and I had 512K of memory on my entire platform and 26 terminals that ran off of 1200K of memory. And now I have that. I have what, 1 trillion bytes in this phone.
Right.
It's amazing.
Yeah. When the internet started, I had heard about the internet, and it was in 1992 or 93 when the government, the U.S. government, officially turned over the www over to private enterprise.
Right.
So I'm not all that technically savvy, certainly back then, but I said, this is something really special. So I went to Washington, which is my hometown anyway. So I used it as an excuse to go to Washington. And I witnessed these engineers with the broken horn rimmed glasses and the plastic pen holders.
Yeah, the pocket protectors.
Pocket protectors. And I was there for 2 days, and I didn't really understand much of what they were talking about. But when I got done with that, I called Tim Grady. I said, Tim, he's been with me for 25, 26 years. I said, I don't know what this thing is called the internet.
Right.
I know the universities have been involved in it long ago, along with the government, but I don't see what this is going to do for us, but it's going to be big. And that was such an understatement that it was amazing. And here we are talking from miles away to one another on a computer and so on. So it's really quite amazing. And thank goodness for Zoom this last year and a half.
Yes. We use Teams a lot in our organization, but I mean, there's a lot of different platforms out there in regards to communication. So, I mean, it's had an impact in regards to how we present stuff to customers and how we have our meetings. We don't actually have to be face to face as much as we used to. So, there's a lot of changes. It's an exciting time right now.
So, what obstacles are you seeing in your particular industry sector?
Right. Well, I mean, because there's less components, you're gonna have to retool based upon what kind of parts you make for these cars going forward. So we have to adapt in regards to the tooling technology we have that gets applied to these new components. The parts are not as big as they would be for like an engine block. So one of the things you have to work on is they can be put on a smaller machine. But if you think of a stator or a motor where you got the copper wiring and the stator rotor that rotates within the housing, it's relatively large. So you have to figure out how you can make a large tool fit into a small part and make a big bore on a small machine. So you have to worry about dynamics of forces and stresses that are putting on the tool, the spindle and everything. So a lot of the tool designs have to go into that equation to a finished product. So that's some of the challenges that we're facing right now and actually how to produce these parts. So that's on the stator side of it. When you start looking at battery trays for how the cars are holding batteries, those start off as extruded aluminum components and then they weld them up. Well, you actually have to cut these parts now dry where you would use coolant in the past with some kind of emulsion to cool a tool because you're going to weld these parts afterward. They have to be completely free of debris and residue. So some of the challenges with that is actually how do we produce these parts completely dry in a cutting environment, which if you know cutting tools and cutting aluminum, it doesn't really work well all the time when cutting something completely without lubrication. So there's some multiple challenges that we're facing right now in tool design and application.
I'd like to just remind some of our late arrivals to our show that I'm talking with Mark Blosser from Ceratizit. And I know the more I say it, the more proficient I'm getting at that.
I'm proud of you, Lou. You've nailed it every time, sir.
Boy, not even one flub. That's great. So, and the website address is
www.cuttingtools.ceratizit.com, and that's cutting tools, CUTTINGTOOLS.ceratizit, CERATIZIT.com, COM.
I'm really beginning to like the name Ceratizit.
That's a mouthful. Yep. Yeah, and in this part of the world, we're not as relatively known as we are in Europe. The Colemet brand is probably more recognized within the U.S. But we're starting to make an impact. We have some really exciting tools that were coming out, and we're going to be presenting relatively soon at the SME show in Greenville, South Carolina at South Tech. And we're doing a lot of these different platforms now and introducing the whole group. So it's exciting for us. Yes.
Excellent. The the way we're going and the progress in the automation and the ideas that are just popping up one after another, it's just amazing that we're living in this time frame, and we don't have to wait long for new technologies to come along. Just wait about 8-9 months.
Right. Well, here's like one right here in my hand. I mean, this is something we just introduced this year. So it actually uses a radio interface to the machine, and the tools can now set themselves based upon machine data sending information directly to the tool. So this is something we didn't have a year ago.
Could you hold that up a little closer to the camera? Let's take a little deeper dive there. Yeah, there's a lot of machining in that.
Yeah, so this is a boring head. So it would actually create a bore and a part. And in the past, you'd have a mechanical dial on here that an operator would go up to with a vernier scale, and he would make an adjustment on the tool to make an adjustment on the tool diameter that it was creating. And part of the Industry 4.0 that we were talking about earlier, you want to be able to have a control process where the machine and the post-process gauge talk to themselves. So this uses a Bloom radio interface, and it gets connected to the machine so you can measure your part. And then the next time it asks this tool to come up in the machine, it actually adjusts the tool automatically before it cuts the part. So you don't have to have the operator go and adjust it anymore. So this is some of the newer technology that we're coming out with.
How much training is required for the man on the shop floor to be able to deal with the new technology?
Well, I mean, you're going from using manual machines to a CNC machine. So most companies that you deal with, they actually have some kind of computer numeric control with the machines already. And they're familiar on how to set up and use probes to probing a part to figure out where their work offsets are before they cut a part on those machines they currently have. So all we're doing is taking two technologies and we're marrying. So a boring head, which everyone's been using for the last 100 years, we've now made it digital. And we're actually able to communicate to a machine with a probe that they're already familiar with, that's been probing parts already. And now we've just closed that loop. So we're using the technology that you're familiar with another technology they're familiar with, and just putting the two components together and making it more simple and more lights out, as we would say, where the machine sets itself.
So there are two aspects that I say. One you just mentioned, where there's a huge benefit, and that is that you can do a lights out operation and operate 3 shifts and pay for 1. And the other is, don't escape me now. It's escaping me. It's gone.
Okay. Well, I mean, it's like it enables it where you have to stop a machine to have an operator physically could go adjust something. You're going to have the machine pretty much set itself. So that gives your time for your operator to do more other value-added stuff like measuring stuff offline and doing multiple machines versus one machines. It's just making everybody at the end of the day more efficient and making them more productive, which actually reduces costs and makes them more productive. So it's a benefit for everybody.
One thing that we didn't talk about, and I want to make sure to bring it up, and that is that I would think that the rejection rate would plummet.
Oh yeah. I mean, one of the things that we were talking about is like with the tool monitoring, you can actually monitor a process with a tool and the entire machine and make sure it never deviates from it. And then you actually can put all the external factors into it, like post-process gauging, in-process gauging, and autonomous tools like the one I just showed you. So you can pretty much guarantee that you'll never scrap a part or create a bad part in regards to 0 defects. So that's pretty much everyone's goal.
So in a machine shop operation like you deal with, what would be considered under normal circumstances without all of the technology? What would be the rejection rate in a machine shop operation compared to a rejection rate with the new technology that you're doing?
It varies by industry. I mean, it really does. I mean, automotive, they strive for a 0-part defect environment. I mean, GM, Ford, Chrysler, they all give out awards to the subcontractors if they actually supply 0 defects for the entire year. So ultimately, in that kind of environment, they're looking for 0 regards to scrap. Now, if you have a smaller shop, it actually hits the owner's pocketbook much more strongly than versus the big 3 in regards to subcontractors. So there's a little more care in regards to how you make those components to make sure you're not scrapping them. So a tool like that is really beneficial for them. So instead of relying on an operator to make a manual adjustment where he could make a mistake by adjusting it further than he should, or not changing a tool when he should, it actually gives them the latitude where the machine is actually controlling that now, where it doesn't affect that small business owner in regards to scrapping that part.
Right.
That's the key.
Which makes them more profitable and so on and
Right.
so forth. Not even to mention the reputation that he's got 0 defects as far as his clients are concerned.
Right.
This is really interesting, and I'm going to do it one more time just to make sure. Ceratizit.
Ceratizit.
All right,
You're batting 1,000. You're batting 1,000. You hit it every single time.
Okay, I'm going to quit while I'm ahead. Mark, thank you very much for being on the show. Really appreciate spreading the message around as to what you do and what the automotive industry is doing. And I do appreciate your joining me today. And I would like just to tell our audience that if you want to see this show or any other of our shows, come to jacketmediaco.com and you will see we've got over 700 episodes, audio, video and audio, and only audio. So we took the two technologies and split them apart, and now we get to be seen by double the amount of people. So join us, and if anyone has any comments or questions, you can certainly email us, but go to jacketmediaco.com and you'll be able to reach out to us. Anyone's interested and has an interesting story or an interesting message about your company, your industry, please let us know. We'd love to have you. And again, Mark, thank you very much for you and Ceratizit for joining us today.
Thank you so much, sir. I really enjoyed it. I appreciate it. Thank you.
Thank you very much. Appreciate it.